Yes, class, good morning. Today we'll discuss here very important topics, Rolle's theorems and Lagrange mean value theorems. Both the topic is important because in this topic mostly 2 marks questions come in the board exam. First, we will discuss here Rolle's theorem because mean value theorem is extension of the Rolle's theorem. Then first we discuss the Rolle's theorem, then we discuss the Lagrange mean value theorems. So now we will discuss here Rolle's theorems here two types. First simple meaning and second we will discuss here geometrical interpretation meaning. Then we easily understand the Rolle's theorems. Now Rolle's theorem depend on the real value function. So now let fx be a real value function in interval AB such that means fx a function which is a real value and in this interval, then you can write here easily f is real value function in this interval and this is the r with value of the function is real value and in this interval. Then you can say here fx is continuous in interval closed interval AB. Second you can say here fx is differentiable in interval. Understand here fx is continuous in closed interval. This is the symbol of the closed interval. Fx is differentiable in always open interval. Third point, fa equal fb. So now these 3 points is conditions of Rolle's theorems. Any function these 3 points are satisfied, then this means Rolle's theorems will be applicable. So suppose these 3 points are satisfied, then there exists at least one real value x equals c which is belongs open interval AB. Suppose 3 conditions are satisfied, then you can say minimum at least one value, more than is not limit, but minimum at least one value which have x equal to c AB means open interval AB at such that f dash c equal to 0. F dash c equal to 0 means this. Suppose you are differentiate of this function in this point c, then result will become 0. So this condition is satisfied and then Rolle's theorem is applicable. First we will discuss here general meaning and then geometrical meaning here. First here this is the function, real value function here. Fx is continuous in closed interval AB. The meaning of this, suppose you are draw the graph of this in this interval of this function in this interval, then graph will be drawn continuous without pen lifting, without any break of the graph. So then you can draw, then you can check, so then function is continuous. Second things, simple meaning of this differentiable. Suppose you are putting the all real values of this open interval in this function, the values come is the real. Then function is differentiable. Suppose you are putting here a and b between any real value of this function, a result is come with the real, then function is differentiable. Suppose result is not come the real, then function is not differentiable. So then not differentiable, so then means Rolle's theorem is not applicable. Three conditions compulsory to satisfy. It is not matter if one is one satisfied, two is not satisfied, the Rolle's theorem applicable. Rolle's theorem is applicable when three conditions will be satisfied. So this simple meaning of this, or what is the geometrical meaning of this? Geometrical interpretation of this meaning. The means, suppose you are draw the graph in this real values graph of this function, then every point having a tangent, every point having the tangent, then means suppose you are draw in this open interval, draw the graph of this function, then every point having a separate tangent, the geometrical meaning of this. Third point here, fa equal to fb, suppose you are putting this and first and last value in this function, ending value meaning first and last in this function, then result will become the same. The means function will be applicable to Rolle's theorem is applicable. Functioning Rolle's theorem is applicable in this function. So then when applicable, then you can say that then exists a one real value, means in this function having one point, those name of this point is C. Which point of this? Where f dash c equal to 0, means in this point differentiable value is 0. Suppose in this point you the differential of the function, the result will be the 0. This is the simple meaning. But geometrical meaning of this means differentiable is 0 means slope is 0. Differentiable is 0 means the tangent value of the tangent, slope of the tangent will be 0. Slope of the tangent will be 0. That means in this point tangent will be turn. Always in this point tangent will be turning point. In this point tangent will be, tangent will be parallel to the x-axis. Means differentiable is 0. This is the simple meaning. The geometrical meaning here, in this point tangent slope is 0. Slope is 0 means parallel will be the x-axis. Then we are searching in this point where tangent is parallel to x-axis. Otherwise you can say here tangent turning point of this, means suppose this is the x-axis and this is the A and B point here. So then suppose your turning point, this point here C, turning point, this is the turning point C, and discuss about this point, which point graph is turning. In this point is graph means where is slope is 0. When slope 0, then graph will be turning. So then graph is turning, then you can say this point here graph is turning. So this is the x equal to c. This point I am discussing about this point. So now I will discuss which types of graph are possible. First thing here, in this graph, suppose this is the x-axis, this is the y. Now you can say here this is the A point, this is the B point. A point and B point. Suppose here this is the function fa and this is the function fb. Or maybe graph, suppose maybe in this possible in this way. This is the A point and this is the B point here. The value of this point here fa, and this point also is coming this, the fa equal to fb. Both having the same value, the fa equal to fb, that means third condition satisfied. And maximum point here, this in this point graph having the turning. So this is the C point here. The C point having the tangent slope is 0. In this point slope of the 0. So this is the C point. Where turning point of the graph, this is the point C, then you can say easily here this is the x equal to C. Maybe graph in this way. Suppose graph This is the A point, this is the B point, and in this way possible. This is the function fa, or this is the function fb. The value of the function here, fa equal to fa equal fb. Condition is satisfied. In this point, this is the tangent. This name of this point is C. This is the C. X equal to C. And maybe I'll graph this way. This is the A point. This is the B point, and in this way, this is the A point. This is the B point. Function here fa, here fb, or this we join. The value of the graph function is fa equal fb, and this point having the C point, graph is turning. This is the C point, this is the C1 point, C2 point, and this is the C3 point. Means exist at least one, minimum one, maximum C1, C2, C3, C4, C5, maximum 3, 4, 5, and this is not limit, but at least one point is possible. So here C1, C2, the 3 points here come, here turning the graph. This graph turning this, and this point this and this. This is at the C point C1, this is the C2, and this will be C3 point. In this way graph come. The graph may be possible in these three conditions. Suppose in this condition, suppose in this condition, suppose in this condition. In this condition having the three turning point. So this is the Rolle's theorems. And then we discuss, when we discuss the Lagrange mean value theorem, the 2 point is similar, but after the second point, result will be changed in Lagrange mean value theorem. Just you note down, and one question will be solved, then start the Lagrange mean value theorems. Yes, student, I am taking the short example to understand of the Rolle's theorems. Now, suppose y equal x square plus 2. This function is the polynomial function. We know that every polynomial function is differentiable and continuous. But we are not using directly property here. I will solve step by step here. Is this function differentiable or not? This function will continuous or not? In interval minus 2 to plus 2. I am checking in this interval this function is differentiable or not, continuous or not. So now first fx is continuous in interval minus 2 to 2. Suppose you are drawing the graph of this, then without break graph is drawn, then you can say that this function is, this is the y square equal to x square, y equal x plus 2. This is the parabola. This equation you can draw easily here in this way. This is the means without you are drawing without pen lifting here. Means suppose this is the value of the minus 2, or suppose this value of the plus 2. Means we are easily to draw the graph of this function. Then without pen lifting, graph is not break. Then you can say fx is continuously minus 2 to plus 2. Second things, fx is differentiable in interval, open interval. This is the open interval symbol, and this is the closed interval symbol. How to check this function is differentiable or not? Now, suppose you are putting here x equal 0 in this function. So what value of the y? 0 square plus 2, answer is 2. Suppose you are putting x equal to minus 1 here. So y equal minus 1 plus square plus 2, then you can say here 3 answer. Suppose you are putting here 1 by 2 here. What result here come? 1 by 2 square plus 2, 2 to the 4 to the 8, 1 9, so 9 upon 4. answer will become here equal to 4. Result LCM is 4 here. 4 to the 8 plus 1 9. The result will be 9 by 4. Means every value you are putting here, then this function, that result is coming the real value. This is the real value. This is not imaginary value. All value are coming real values. Then you can say that this function is the differentiable. Third point, fa equal fb, and a here minus 2 and b equal here plus 2. First I will putting here minus 2 here, and minus 2 ka square plus 2 equal to 6. Similarly here f2 plus 2 ka square plus 2 equal to 6. Both the conditions having the same value. That means three conditions are satisfied in this value function. Then you can say okay, Rolle's theorem is applicable here. Rolle's theorem here applicable. And then you can say here all conditions of Rolle's theorem are satisfied. Then so you can say अगर all conditions are satisfied, then you can say कि there exists one real value, then exists one real value at least, then exists at least one real value x equals c, which is belong open interval AB, such that f dash c equal 0. Now I will check this. This what is the value of this c? Where is belong this c is belong minus 2 or plus 2 or not? Then we check here. And we'll check here if this point c is belongs or not. Now function fx, y means fx, value y equal to the fx. So fx equal function x square plus 2. Now differentiate f dash x equal to 2x plus 0 means 2x. When x equal to, I am putting the c here, the f dash c equal 2c. Putting a c, but f dash value of the f dash c is 0. So now if 2c equal to 0, value of this 0 here, then 2c equal to 0, c equal to 0. Now this c, the c 0 is belong to minus 2 to 4. Then therefore c is belong minus 2 to plus 2. Then you can say Rolle's theorem is existing. Now you can say Rolle's theorem are exist. Means c point is exist. C point here, c is 0. C point here 0. You can write here 0 here exists minus 2 to plus 2. That means Rolle's theorem are exist. And applicable and exist. The value of the c point here 0. So 0 is belongs to minus 2 to plus 2. Then very simple things. Means first you will check the every point here. This is all conditions are Rolle's theorem are satisfied or not. Sometimes I am directly using the property of the, suppose your function polynomial function, you can directly write here since this given function is polynomial function, then every polynomial function is differentiable and continuous. But then no need of this point. First and second point, no need of the explain here. Then you will explain here only third point. First and second point, suppose your polynomial function. But here this is the polynomial function by explain here every point here. But this is not required when your polynomial function you directly directly write here is since given function is the polynomial function and every polynomial function is differentiable and continuous, then no need of the explanation of this. You explain this point, then using this and then find the answer. Very simple things of this work. Just note down.